All right, we want to do a couple things in this video. We want to talk about using our calculator to do some plotting. We want to talk about the modified box plot, an outlier test, and we want to talk about resistance. First, just a quick review and maybe an extension of what we've talked about with CUS. Okay, so if you remember, CUS is our way of describing graphs, and the mnemonic here stands for describe where the center is, if there's anything unusual, what the spread of the data is, and what the shape of the data is. So a college professor plots the frequency of scores on her first two exams, compared the distributions using comparative language. So here's what I mean by that. And really we're going to kind of talk about this rather than maybe write it all down. Comparative means what you can't do here is give a list. You can't say, well, on exam one, the center is here, the spread is this, the shape is this, and here's what's unusual. You really want to do almost 4 sentences, one for the center, one for unusual, one for spread, one for shape, that actually compares the two to each other. So here's an example. I think most people would look at this and say, well, based on the data, I bet the median for exam one is in this bin, and this one sure looks symmetric, so it's probably right in here. So you would say the center for exam one is higher than the center for exam two. And that's it. So you're comparing the two. If you want to put numbers to it, put them in parentheses. Say the center for exam one, 80 to 89, is higher than the center for exam two. But you can't just tell what the numbers are. You actually have to use some kind of descriptor that says it's higher, it's lower, they're similar, whatever. All right, let's come back to the U. I like to do that usually last. The spread. You'll notice that at least based on our bin width, 50 to 100, 50 to 100. So again, using comparative language, you would say the spread for exam one is the same or similar as the spread of exam two, at least based on the bin width we see. So again, we're saying there's the similar, they're the same, we're comparing them. Shape. Well, you'll notice exam one is very skewed to the left. Remember, skew, the shape describes where the direction is where the tail is. This one looks very symmetric, very mound-shaped. So we would say the shape for exam one is skewed to the left, while the shape for exam two is very symmetric. So really think about a sentence that has both things mentioned, or both the shape of both and compared. Unusual. Well, we haven't talked about an outlier test yet, but I think most people would agree this looks pretty normal. It looks very regular. It's very symmetric. Something down here could be an outlier, depending what the actual scores are. If you had all 5 of these people at 68, and these 2 people got 50, maybe they are an outlier. So maybe that's what you'd say. You'd say exam one has outliers while exam two does not. Okay. So again, be careful as you talk about comparative language. Okay. All right. Moving on. So here, I had a data collection for my class of their estimate of a night in the Rio Hotel in Las Vegas. So I put this data in my calculator, and let me play that. Okay, so my data is in list 2, and you can see I'm going to make a box plot here, and I do the zoom stat, and there it is. It's an ugly thing. I just really wanted to highlight the fact that you can use the trace function to actually give yourself the 5-number summary using trace, and then kind of arrowing back and forth, you can give yourself the 5-number summary. When you transfer this to a piece of paper, remember with a box plot you need a scale on the bottom. You need to say like, okay, this is 0, and I guess up to 50,000. 0, I guess, go like that. And you can't just make the plot. You have to actually have like a scale on the bottom and axes. And also, remember, you can make use of this old trick, remember, where you do something like that and then pick up, especially with this where we have 2 data points that are so much higher than the rest. So make sure, practice doing that on your calculator. Make sure you can do a box plot. I wanted to show you how you could get some descriptive statistics very quickly using your calculator. I'm going to go back and use the number of shoes, the data collection I did on my class of number of shoes in their closets. And you can see these are pieces of data that you could in no doubt find by hand. But I wanted to show how we could do this using the calculator. So let me hit play. You can see the data is in list 1. And I press Stat and Calc and one variable statistics. Now, I'm just going to pause for a second. If you have the old calculator, it pops you out to a blank screen that just says 1 var stats. If you press second 1, it will give you a list 1. And this way you can say, well, I want the stats in a different list. When you hit calculate, it pops you out to look like that. You hit enter, and you can see it gives you a whole set of data. The very first piece of data there, the X with the little line above it, this is called X bar. That is the mean. That is the very first piece of data. So 11.1. Let me just write that down. Now, we also, you'll notice a little arrow here on the bottom. That means there's more stuff down here you're not seeing. So you can use the arrow button and go down and see more data. So I'm going to do that. And there you can see now the whole 5-number summary. The minimum, Q3, the median, or the Q1, the median, Q3, and the maximum. So if I fill in the median, it was 6. I guess the range is from 45, or from 2 up to 45, so 43 is the range. And the mode, most occurring value, we actually will look back here. It's 3 pairs of shoes is the most occurring. Okay. Let me go to the next slide, and we're going to use the quartiles for something. All right. So again, we had our quartile 1 was 3. Our quartile 1, our quartile 3 was 18. So the interquartile range says how far, what's the spread there? And of course that's 15. Now, an outlier test. The outlier test is something you learned a number of years ago, and there is some mathematical kind of intuition that goes into it that maybe is too long to explain in this short video. But the test really comes down to the fact that you have your IQR, and you multiply that by 1.5, and this gives you a distance that you use to create what are called fences. And you say anything beyond the fence is an outlier. And here's how you use this. You take your Q1 and subtract your IQR times 1.5. And you take your Q3 and you add your IQR times 1.5. So our IQR was 15, so 15 times 1.5 is 22.5. So 22.5 minus 3 minus that is negative 19. We don't have anything down there. But 18 plus 22.5 is 40.5. So you can see we do have an outlier. 45 pairs of shoes is an outlier. So a different box plot called a modified box plot is one that actually would allow us to create the plot in a way that we could see the outlier. So I'm going to go 0 here, and let's do like 10, 20, like this. The middle part is still the same, right? Our median, or our minimum, well, 3, 6, 18. So this is still the same, right? Now, a box plot is really all about data. Okay, it shows data, not these fences. The fences will not appear on our box plot, but they are used in order to help us gauge where the data is in relation to the outliers. And what I mean by that is that because our minimum value was 2, there's nothing at negative 19.5. The bottom still will look the same. It's going to be at 2. But the top, we did have an outlier at 45, and we put a dot at the outlier. And the line that we put as our upper line in our box plot will be where the last piece of data that wasn't an outlier appears. So at 35, like that. So again, we don't include the fences because there was no one with 40.5 pairs of shoes. So we don't draw up to the fence, we draw up to the last piece of data that wasn't an outlier. And you can do this on your calculator. Let me just drag this in quick and you'll be able to see. So again, if I've got my data in list 1, I change my plot. This plot right here was a box plot. You see this one next to it is a modified box plot. It's got the little dots there. So, if I hit play, I do my zoom stat, and there's my modified box plot on the calculator. And again, you can hit trace, and it's done all that work for us. So one last real quick little discussion of the mean and median. A lot of this stuff you already knew, but it's worth visiting about. The mean is what we call not resistant. Okay, and by resistant, we really mean outliers. If I removed 45 pairs of shoes, the mean would drop quite a bit because you drop from having 19 people surveyed to 18, but you would have subtracted 45 off your total. The median, on the other hand, would just shift a number over. You know, you had got them in your list of ordered, and it would just shift over. So the mean is not resistant to outliers, but the median is. The mean is not a number from the data. It's calculated, right? It wasn't possible to have 11.1 pairs of shoes. But the median is a number from the data, or it's an average of two actual numbers from the data. So the mean we don't calculate, or we do calculate. The median we don't. The median really does need to be in the middle of the data. It's the center number. The mean, the only thing we know about its range is it's somewhere between the minimum and maximum. Depending on an outlier, the mean could be pulled very, very high and have very few numbers above it or below it. And again, that's another reason we say it's not resistant.